OSPF introduction. A very good routing protocol, which is seen very widely used both in enterprises as well as the service provider level. Not only that, even in data center, we do have OSPF or ISIS, the link state routing protocols. So Open Shortest Path First is a protocol that is seen in many places. So it is worth learning, spending some time in understanding this protocol, OSPF. Thank you. Open. The reason why we open, because it is a routing protocol built using an open standard algorithm called SPF. SPF, which is also called as Dijkstra's algorithm, it's Dijkstra. That's how we had to say Dijkstra. Just the name of the person. Dijkstra. Dijkstra's algorithm, also called as binary tree algorithm, which is an open standard. And this routing protocol uses that algorithm, which is already open standard. So that's one of the reasons why it is called as O. Another reason is, you see, because it is not a proprietary one, because it's not a proprietary protocol, every vendor uses this. So when I have a Cisco switch, a Cisco router, and a non-Cisco router, they are open to talk. They don't have problem. They are open to talk each other. They are ready to talk each other. They are open to talk each other. Open means readiness. Open shortest path first. Now this comes under link state routing protocol. Link state. If you go back and see EIGRP and RIP, what do they advertise? They advertise information from the routing table. Both EIGRP and RIP, they are distance vector protocol. The distance vector protocol, the information they share between the routers are not providing the complete topology information. They only provide the best routes which are seen in the routing table. Only those best routes from the routing table is given to neighbor. Routing table will have only the best routes, and routers are only going to give the best. What about the other routes? EIGRP don't share those other routes. RIP also don't share those other routes. Only the best they share. But this protocol is a link state protocol. Every link and their status is informed as an information to the neighbors, as an update, route updates, route informations to the neighbor. Every single link's information. All right, it's a link state routing protocol. As a result, the router which learns the information learns the topology. Because the neighbor did not give just the routing table, not just the best routes, the neighbor has given complete links and their networks and their cost. So which makes every router to learn the real, complete topology without any hidden path. The true routing table, the complete routing table, topology table, the true topology table, the complete topology table you can see in OSPF but not in EIGRP. In EIGRP though you got topology table, they are not really topology table always, because the routers, they advertise only the best routes. And the learning router will not know the other routes other than the best routes. So they cannot have the complete topology info. Whereas OSPF can maintain complete route information. Complete route information. I need to say complete topology information. When I say route, don't go into routing tables route. I mean the paths, complete links, the roads of the topology, the links, the roads. So the link state routing protocol shares link state information, not just the routing table. Secondly, when a router receives the link state information, it understands the topology and it can find the best path for the destinations. Whereas the other routing protocol that you have learned, they not only learn the route information, they also learn the metric like hop counts, advertised distance, We call it as learning by rumor. Learning by rumor is not good. Checking, verifying, and deciding the route is the best. In OSPF, you can check, verify. The routers can check and verify and pick one best route by itself. They don't depend on the other routers to give. They don't depend on the other routers to give metric. Whereas in RIP, hop count metric is given to the neighbor. If one router says hop 5, and the receiving router will believe that, okay, for me, hop 5. What if that's a false info? No chance to verify. The receiving router has to believe it is 5 hops. Because the neighbor is saying 5, it has to trust. Whereas in OSPF, the link status information is shared to everyone, and everyone looking into the topology table, they will know which is the shortest path for them, and the shortest path will be assigned to the routing table. You see, the big database gets built by collecting all the link state information, which is coming as link state advertisement. And every router will have this database. Once the database is created, this is what I call it as topology table. Topology information table, LSDB, on top of which the SPF algorithm, the binary tree algorithm, the Dijkstra's algorithm runs, and picks the best path for each destination and puts the best path gives the best path to the routing table to use. See, it is the routing table which is going to decide whether to take it or not, but OSPF will recommend after running SPF. OSPF will recommend to the routing table manager called a RIB or a routing table manager. The routing table manager will take it and use it. If routing table manager finds something else better than this OSPF, then the routing table manager will use that one. For example, EIGRP gives route for a destination. EIGRP administrative distance is 90. OSPF, after running through the LSDB using the binary tree, OSPF also gives a route for the same destination. OSPF administrative distance is 110. Now the RIB, the manager, will use only EIGRP route. You see, the final decision maker is not OSPF. It's the routing table manager. The protocol whose administrative distance is lower will be used. Is it clear so far? As I told you, OSPF also got 3 tables: neighbor table, topology table, and then the routing table. Neighbor table will have the neighbor information. Neighbor informations are maintained. But to become a neighbor, there are some criteria. The neighbor need to be member of same area. We'll talk about area a bit later, but there is something called area which groups a router. If you do not know, but I'm sure you know it. So if the area ID is not matching in the negotiation packet, in the hello packet, the neighbor cannot get established. So after checking the timer, the hold time, the subnet mask, the area, the subnet, after checking all those criteria, when they all satisfactory and matching, the neighbor table will have the neighbor. Neighbor table is also called as adjacency database. Next is the topology table. Topology table, as I told you, it is LSDB. This contains all the routers link state information that are attached to the routers. And this information, this LSDB, this topology table information will be identical at least within the area. Very important. Don't compare one router's LSDB in one area to another router's LSDB which is in another area. It won't match. But within an area, you can guarantee. Within an area, you will find identical database. And about the routing table, we all know. The best paths to all the destinations will be put into the routing table. And if the router is seen in the routing table, then the route will be used for forwarding the packets. So the routing table can also be called as forwarding database. Because based on the routing table info, the packet will be forwarded. That's what I said, not OSPF info. OSPF info need to be accepted by the routing table. If it is accepted, then it is OSPF info. But what if it accepts only EIGRP because of administrative distance? So in routing table, if you have OSPF route, definitely it will be used in order to do packet forwarding. So routing table in common, we call it as forwarding database. Whether it is OSPF given or EIGRP given, that doesn't matter. Now, what is the advantage of this link state routing protocol? You see, what is the advantage of having a map? You have a map of the city. What is the advantage? When you have the complete map, first you will see in that map where you are situated. Where is your house? Fine, here I am. Now, where do I want to go? That is your next search. Okay, I need to go there. Now you will see how many paths available. Among all this path, which one is the best? So you can make what? You can make an accurate decision because you got the complete map. In EIGRP and in RIP, you don't have the complete map. You don't have the complete map. So when you don't have the complete map, it is not possible to provide the best route, the accurate route. It may be a route, but it may not be an accurate route. Yeah. So only a link state routing protocol can provide you the complete map, using which you can make accurate decision. See, because it provides you the full picture of the topology, you can do that. Not only that, if one path goes down, you don't need to query like EIGRP. You will see that in the database and you will immediately use it as the backup path. You don't need to query someone. If database don't have, which means what? The route doesn't exist. And the primary path goes down, it will look into the database. If database have got the alternate path, then it uses. If you don't have an alternate path, what does it mean? It means that the route doesn't exist because it has got the complete map already. It's not incomplete. In EIGRP, it is an incomplete map. That's why it is querying and waiting for the reply, stuck inactive, all this headache. You understand? Immediately, the update will be sent and then information will be updated to the database. Immediate flushing update. Of course. When the primary path goes down, immediately the SPF algorithm will recommend the other shortest path to the OSPF algorithm, and OSPF algorithm will recommend it to the manager, the routing table manager. All right. Now, this OSPF has got a hierarchical design, hierarchical network structure in order to support a very big network. For scalability, you need to follow two-level hierarchy. See, OSPF, if you follow these rules, then this OSPF is the best protocol. You will feel that this is the best protocol. If you keep it as flat area, one single area, then you cannot expect big scalability there because you will have summarization issue. You cannot do summarization when you are just having one area. I repeat, when I don't have many areas, What does it mean? I just got only one area. When I have only one area, I cannot do summarization. Why? Summarization is done only between the borders. You won't have border if you don't have areas. So you cannot have effective path selection. You cannot have effective routing protocol when you don't follow this rules. Two-level hierarchy. All areas, meaning you will group the common routers with common route policies in one area. So likewise, you have multiple route policies, then you will have multiple areas. Routers of same policy will put together as one area. Different policies, different areas. And all these areas need to be connected to a common area called backbone. Mandatory. Without the backbone area, the non-backbone areas cannot form adjacency, cannot share any routes. Backbone area is compulsory, mandatory, important. Without that, two non-backbone areas cannot share any route updates because they cannot form neighbor. You see? If I want to form neighbor between these two, is that possible? Not at all possible. Why? This interface is area 1, this interface is area 2. If area ID don't match, they don't form neighbor. And they cannot share any routes. But when you have a backbone area, always area 0, number 0 is reserved for backbone. When you have backbone area, you see this two endpoints, area 1. And this two endpoint, area 0. They don't have any problem in forming neighbor. And now routes of area 1 will be shared to area 0 only. If this is area 100, C will not share the routes. Area 1 route will not be shared to area 100. Only to 0 it is designed to give. And from 0, it is designed to give to other areas. So what I am trying to say in short is, area 0 is the transit area. It's the middleman, it's the mandate, it is the backbone. Area 0 is the transit, it's the mandate, it's the backbone. All other areas are called as regular areas. Other than 0, all other areas are called as regular areas, non-backbone areas. As I told earlier, without areas, you cannot do even summarization. So when you do summarization, what happens is you are able to minimize the routing table entries. See, all the hundreds and 200 and many hundreds of network, you will summarize and send. As a result, the other areas will have minimized routing table. If you don't have areas, you cannot do summarization. You cannot have minimized routing table. What is the advantage of minimized routing table? When you have routing table small, the routing will be much faster. The decisions are made quicker. Yeah. Memory utilization also decreased. Process utilization is also decreased. Time taken is also less. So it improves the efficiency of your whole network. And when something goes wrong in one area's one small subnet, it will not impact the other area. It will be only localized because you have not sent all the detailed route. You have only sent the summary. So the impact is localized whenever the topology change occurs. As I said, detailed advertisements are not sent to other area. The detailed advertisements are stopped in the border. Only the summary is sent. For all these good reasons, we need a hierarchical network design. This A and B are backbone areas. Yes. And backbone will forward to other areas. Of course. Yeah, this will be a first lab. Remind me if I am doing some other lab. Remind me. You have to remind me, please. Summarization. Anyway, the summarization portion is coming later, but because you have already learned OSPF, I want to go in your level, super fast level, the hero level. So we will do this as the first lab. When the portion comes, you no need to do again. Huh? Okay. Now, this A and B router in this picture are called as backbone routers because their interfaces are not in any other area. They're totally into area 0. And you can also call it as area 0 routers, backbone routers, all the same. C, D, and E are in the border. Why I'm saying border? Because one interface is in area 0, the other interface is in other areas like area 1, 2, and 3. So they are called as border routers, area border routers. And this F, G, and H are non-backbone routers. They are internal to their respective areas. Non-backbone router. Now, how does the neighbor discover? OSPF, as soon as you enable on an interface, it starts sending a hello packet on that interface. This hello packet will carry the router ID, the area ID, the subnet, the network, the timer, all this thing. We'll talk about that in detail later. Now, these hello packets are sent to a multicast address 224.0.0.5. When a packet is sent to this address, everyone that runs OSPF can hear the packet, can receive the packet. No others can open the packet. Only those OSPF running routers will open the packet. See, when I send a letter telling this letter is for Bala Group of Company. Now, when that letter comes, anyone in your company can open the packet because they all work for Bala Group of Company. Because in the letter it is said to anyone in Bala Group of Company. Now, when that letter goes to Apple, the Apple people will not open it. They will say, hey, no, this is not our company's letter. Microsoft will not accept, no, this is not ours. This is Mr. Bala, Dr. Bala, the latest space research scientist and co-company. So only they can open the packet and see the info. No others can open. It's the hello packet that makes the neighborship negotiation to begin. Now in the hello packet, a lot of parameters comes. They compare the parameters. When certain parameters that's supposed to match matches, after checking those parameters, then the neighbor is declared. A router which is connected is declared as a neighbor router. If the parameter doesn't match, no neighbor. What are the parameters is coming in the next chapter. Let us not get into it now quickly. No. So, hello packets. How often these hello packets are sent? It is sent every 10 seconds. But there is an environment called NBMA environment in where you can see 30 is the hello timer. Don't worry about NBMA. It's no more. We don't have that NBMA frame relay, X.25, ATM technologies. We'll talk about those things later. It is coming, but not now. It is too less important. Now, OSPF forms full adjacency when you have a point-to-point neighborship. What it means, I have two routers connected through a serial wire. The serial wires are called as point-to-point links, WAN links. Here, the encapsulation, if it is Cisco, it is going to be HDLC, not Ethernet. It is HDLC. If it is non-Cisco, it will be PPP. If any one of this is encapsulation, then it is called as point-to-point WAN links. So OSPF can easily recognize that I'm running on a WAN link, so I should not have any other adjacency, only full adjacency. Full adjacency. Whereas in the LAN link, we may have more than we may have only two routers. But the problem is because it's a Ethernet link, whether you're connecting through a switch or not without switch, because it is Ethernet, OSPF understands that I'm running on a LAN link, Ethernet link. So there may be some switch, there may be more routers. So to avoid looping situation, I need to select a leader and assistant leader called DR and PDR. Only to them I need to have full relationship, full adjacency. With all others, I should have two-way relationship. More detail is coming later. This is only to prevent duplicate information sharing and loop avoidance. As of now, what we learn here is in a point-to-point environment, the neighbors will have full adjacency, meaning they will share every. That's what I'm doing right now. In a point-to-point environment, they form full adjacency, and they share all the changes that happens with each other. Whereas in a LAN link, whereas when there is an Ethernet link, there will be an election. There will be one router as a DR, other as a BDR. If you have more than two routers, then the third router will be DR other, fourth router will be DR other. This type of election is to avoid duplicate information that cause loop. So only with the designated router and backup designated router, every router will have full adjacency, meaning they will share everything. With the other routers, they won't share everything. They will simply send the hello packets. More info than this, if you need to wait for the flow for other chapters. It's coming later. Now, whenever there is a change, then the LSAs are flooded throughout the areas. And when you do summarization, they are localized, they are not sent to other area. As I said earlier, the LSDB is built by collecting LSAs. On this LSDB, which is identical within an area, every router will place themselves, like I said, map is given to Bala, he's in a new country. First thing, he will position himself in the map. Likewise, every router will place itself into the root of the tree in the database. And from there, if he wants to go to Pentagon, Bala finds 10 different paths. In that, one path has got the low cost. So Bala picks the best path, the low cost path, after calculating using SPF algorithm, and puts that path into the routing table for packet forwarding. Again, OSPF is not going to put into the routing table. OSPF is going to give the recommendation to whom? To the manager, routing table manager. Routing table manager will put it in the routing table for packet forwarding. See the tree here? The shortest path. Assume that each link cost is 10. This is 10, 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 this is 10. That's what they say. Now, if someone wants to go to F from X, see, this is Bala sitting here in the United States, and F is the Pentagon. Now, if he goes this way, it is 10 plus 10, 20, cheaper. There is also another route, 10 plus 10 plus 10, which is 30. He will not do it. He will not use it because that's not shortest. So all the dotted lines he ignores after running the Dijkstra's algorithm. You understood this. Now I want you to have a close look into this picture for a minute. After a minute, I'm going to explain. Now, please, what did you understand from this? Then let me do it. Let me tell you. Let me tell you. You see, a packet is entering into the router. It may be many updates put together called LSU, or it may be a single update, LSA. It is coming. If this is a fresh router, if this is the newly running OSPF running router, if someone just enabled OSPF and formed a neighbor, just formed neighbor, then the database will be empty. There won't be any entries. There won't be any entries. No is the answer because there is no entry in the database. So whatever comes in will be added to the database. And then an acknowledgement will be sent back to the person who sent the update. The receiver will send an acknowledgement to the sender. After that, this router which has received it, it will flood the information to the other downstream neighbors, and on its own database, it will run the SPF and find the new routes and put the new routes into the routing table. So this is when the database is empty, fresh. What if I see already some entries in the database? I see already something in the database, some route information. In that case, what is the sequence number? If that same neighbor sending LSAs, then sequence number will be incremented. Last time he might have said sequence number 10. Now he will say sequence number 11. Is the sequence number same? If it is same, then I don't need to learn because it's the same update. Ignore. If the sequence number is not same, is it higher? Higher means what? It's a new update coming from the neighbor. Last time he sent 10, now he's sending 11, which means if the sequence number is incremented, which means he has got something inside the update, something new inside the update. And now it needs to be added to the database. Added. This A, no? A. Added. So it's a nice way of writing a drawing flowchart. Instead of drawing one line like this, they have drawn like this. It's okay. What if the sequence number is not higher? Which means earlier he sent 10, I already have 10 sequence number for that update, but someone is sending me that same update with a 9, which means that someone is not updated. To that someone, I need to send my LSU so that he can get updated. Any question? Where it is not clear. No, I did not say it will not add. If the database is empty, then you can blindly add whatever is coming in because you are already empty. But when you already have something in your database, check whether your database sequence number and this LSU sequence number is same. If it is same, then ignore. Just ignore. Because what is coming is same thing only. If it is not same, then it should be higher or lower. Maybe this is 11. But what you have is 10. If it is higher, what does that mean? This has got some new information. That's why neighbor is putting 11. Whenever there is a change, he will increment the sequence number and the neighbor will send it. Because it is having some new information, then it needs to be stored into the database. Yes or no? If it is not new information, which means it is older one. Whoever is sending old one. He is sending 9. So, not ignore. This router will inform the sender that you are having an old one. Take mine. I'll give you mine. See, this router is sending a LSU with a newer information to the source. You understood? Now, source is also getting updated. This is how one router helps the other router to get synchronized with the latest topology. Is it clear? No, my dear. Listen. Not sending back and all. Bala is sending me. Bala is sending me 11. I'm having 10. So whatever Bala sent me, I have to update to my database. After updating my database, I'll send the acknowledgement to Bala. Thank you, Bala. I got your message. And then I will send this to Ganesh, Ramesh, Suresh, who is my downstream neighbor. And then I'll calculate with the new SPF, and then I'll update to the database. I updated what Bala sent, and my 10 became 11. But now Kamesh is sending 9. Same update. This time not Bala. Kamesh is sending, hey, I got an update. No, my dear, listen, listen, listen. Again, you are repeating the same statement, ignore. That's why I'm repeating. When it is not same, it will check whether it is higher. If it is not higher, which means it is lower. Yes or no? It is no, lower. So I will send Kamesh. Kamesh, you are the source who sent me with a 9. My friend, you don't have the latest one. I got 11. Take it. So it sends to the Kamesh. That's all. All right. So few more additional things from the summary. They send a hello packet every 10 seconds. Not only that, they also send all the updates, means LSU, every 30 minutes to make sure that no one is missing anything. You understood? In order to make sure everyone knows everything, it is going to send update every 30 minutes. Many people do not know about this, right? All of the things we have seen in this chapter. All right, we stop here.